CRD 1.6, Solving Radical Equations. It's kind of an odd name for this lesson because the first half of the lesson is dealing with radical expressions, and the second half of the lesson is dealing with radical equations. So first, let's note the difference between the two. Remember, expressions don't have an answer, and they also don't have an equal sign, and all you're doing is actually simplifying them. So everything on this page is an expression. In the next couple of pages, we'll deal specifically with equations. And equations, remember, we're solving for x. We're trying to figure out what x equals to make the equation true. When dealing with both or any radical problem at all, you have to remember simplest radical form, which we talked about in the last lesson. There are no perfect square factors in the radical. There are no fractions under the radical, and there are no radicals in the denominator. So always keep that in mind so that you get the correct answer and simplify it as far as it can go. So looking at this page, it's just an important distinction to make. Square root of 3 times square root of 3 and square root of 3 plus square root of 3 are both very different problems. Square root of 3 times square root of 3, just like with x's, I can multiply radicals. Square root of 3 times square root of 3 is square root of 9, and the square root of 9 is 3. Some people will take something like this and jump straight to the answer because they see it's square root of 3 times square root of 3. So that's also the same thing as saying square root of 3 squared. And a square root and a squared kind of undo each other, and you get 3. Other people prefer to think about it as square root of 3, square root of 3, square root of 9. Oh yeah, that's just 3. Either way is fine with me. The second problem is different though. If you have the square root of 3 plus the square root of 3, it's like saying I've got 1 square root of 3 plus 1 square root of 3, so I actually have 2 square root of 3. It's just like combining x's. X plus x is 2x, right? Same idea. So here I have 5 root 3 plus 4 root 3. So how many root 3's do I have? 9 root 3. Okay, so you basically put them in a pile together and you have 9 of them. Here, I've got 3 root 5's and 5 root 3's, but my radical is different. So these are like unlike terms, and I actually cannot combine them. So this is already simplified because the radical is different. These two problems, you think to yourself, well, the radical is different, so it's already simplified. But actually, that's not the case because the square root of 72 and the square root of 18 are not in their simplest radical form. So first, let's put them in simplest radical form. Square root of 72 is actually square root of 36 times root 2, or 6 root 2. Square root of 18 is square root of 9, square root of 2, or 3 root 2. So this problem actually is 6 root 2 plus 3 root 2. And if I put 6 root 2 and 3 root 2 together, they have the same radical. So my final answer in this problem is 9 root 2. So it's a little bit trickier, but that's how it would work. If I take a look at this one's slightly different, but also similar. I'm going to put a line there. My 72 becomes 36. My x squared is a perfect square, so I'm going to also keep that under the radical. And then what's left is root 2. And over here, I have 5 times, my perfect squares are 9x squared. My unperfect square is root 2. So now if I undo my perfect square, I get 6x root 2. And over here, I have 5 times 3x root 2. So I basically have 15x root 2 plus 6x root 2. Which, if I combine those, the radical is the same. So I have 21x root 2 is my final answer. A little bit tricky. Okay, but it's in simplest radical form, and those are the expressions. Okay, if I move ahead to equations, now I have an equal sign. Now I have something on both sides of the equal sign, and I have an x. I'm trying to figure out what the x is. Okay, so the rule here is that you want to get the square root isolated. You want to get it by itself. I don't have to get it by itself in this case when there's multiplication, but it is a good practice to get into. So if I want to split 5 times root x, I'm going to basically divide by 5 on both sides. The 5 goes away, and I have root x equals 7. Now to undo a square root, to get x by itself, I basically have to square it. So if I square square root of x, I get x. If I square 7, I get 49. So my final answer is x equals 49. For my check step, I'll do that in red, I would have 5 times root 49 equals 35. 5 times 7 is 35, and that's true. So I know my final answer is correct. Okay? Now, if I go back to if I go on to my next question, I have 5 root x like I did before, plus 9, no. Now I have this plus 9. And I do have to get rid of that because I have to get the x isolated, or the root x isolated. So I subtract 9 on both sides. I get 5 root x equals 35. This should look familiar. Divide by 5, and I get root x equals 7. Square both sides. X equals 49. If I go ahead and I check it, I have 5 times root 49 plus 9 equals 44. So I basically have 5 times 7, 35 plus 9. Does that equal 44? It does. So I know I got this right. Okay, now I'm going to hit more of a funny one here. Of course, I like to give all the tricky ones here in the video so you don't feel confused when you're doing the lesson. If I try to isolate the root, I'm going to subtract 9 on both sides. I'm going to get the square root of x equals negative 5. So there's 2 ways to go about this problem at this point. The square root typically does not equal a negative number. It can sometimes, but when you're doing it with a variable like this, it won't. You think about the square root as the positive or the principal root. So some people look at this and they know there's no solution. Other people don't. They keep going. So they say, I'm going to square this side, I'm going to square this side, I get x equals 25, and I'm done with the problem. But the problem with the problem, or the problem with the answer, is that when you go to check it, you're going to take the square root of 25 plus 9 equals 4. The square root of 25 you're going to think of as 5. You're not going to think about it as negative 5. Plus 9 equals 4, and that is not true. So right here in the check step, you say, oh, my answer isn't this. The answer is there is no solution. So either if the radical equals a negative number, it's no solution, or when you check it, it doesn't make sense, there's no solution. Okay, tricky. Okay, so now we've got 3 more problems we're going to do, just for practice. So again, I want to get the radical by itself, so I'm going to add 9 to both sides. I'm going to get the square root of 5x equals 10. I'm going to square both sides. I'm going to get 5x equals 100. I'm going to divide by 5 on both sides. I'm going to get x equals 20. Of course, I want to check it just to be sure I didn't miss something. Square root of 5 times 20 minus 9 equals 1. 5 times 20 is 100. Square root of 100 minus 9 equals 1. 10 minus 9 equals 1, indeed. So this answer is correct. Okay, this one. Now, I'd like to get rid of the 2, but there's nowhere for it to go because there's a radical on both sides. So what I'm going to do instead, and I'm going to erase this just because it's in my way. What I'd like to do instead is I'd like to move it, but I can't move it because these aren't like terms. There's nothing I can do. If I divide it by 2, I just have divided by 2 over here. So I'm going to leave it, and I'm going to square both sides. And I can do that because 2 is multiplied with the radical. Here, the radical has a subtraction with it, so I can't do that. But here I can. If I square this side, I'm going to simply get x plus 8. If I square this side, I'm going to get 4. Times root 5 is 5. So I get x plus 8 equals 20. Subtract 8, x equals 12. Now, just for good measure, I'm going to make sure I got this right. Let's check it. I've got square root of 12 plus 8 equals 2 root 5. This is square root of 20 equals 2 root 5. Square root of 20 splits into 4 and 5, 2 root 5. I have 2 root 5 equals 2 root 5. Indeed, that works. So that is the answer. Tricky. Okay, my final question. And I'm going to erase because, oops, I'm going to erase because this is in my way. All right. This is like the trickiest kind I can give you, probably. If I have negative 5 root 5 plus 28x equals 2 root 5. I've got a radical on both sides. I need to get the radicals together. It's different from the other one because I have a plus on the outside of the radical, so it's tricky. But these are like terms, so I can put them together. So the way I would do that is I would add 5 root 5 here, which would make it disappear on that side. But of course I have to add it to this side. So I get 28x equals 7 root 5. Okay, now I'm not so worried about the radical because the radical's all on one side. I can square both sides, but I need x by itself, and x isn't under a radical. So what I'm going to do now is I'm going to try and just get x by itself. So I'm going to divide by 28 on both sides, and I get x equals the 7 and the 28 work together, root 5 over 4. And I don't have any radicals in the denominator, so I'm okay with that answer. This one's pretty tricky. Now, if I check my answer, I have negative 5 root 5 plus 28 times root 5 over 4 equals 2 root 5. Okay, so first I'll add 5 root 5 to both sides, and I get 28 root 5 over 4 equals 7 root 5. Well, 28 divided by 4 is 7 root 5 equals 7 root 5. So that indeed works. But that is pretty tricky, I have to admit. That's pretty tricky. But I just want to show you how you can move things around. So best of luck with this lesson.